We are going to continue a little bit more with this correlation stuff, and it turns into regression. We need to find the equation of the regression line. So let me try to explain that a little bit by summoning the quick draw. And hopefully I'll still be able to have access to what I need, which is that picture there. Yeah, it's still there. That's good. I need that badly. Okay. So fine, because these three, 29, 30, and 31 really belong together. There's not much I can do about it. I don't have enough space or time to put them all together without stringing them all together. Anyway, here's the story. What you saw in, just roughly speaking, what you saw in video 29, what you saw in video 29 was the beds, and the and the personnel. Personnel, right? So you saw a bunch of scattered dots, and they sort of looked like a line. They weren't it wasn't perfect, but it sort of was going like a line. All right, that's approximately what you saw in video 29. Now we want to plot the line itself, the line that's really what this is sort of tending towards. What is the equation of this line? That is the question. What is the equation of that line that basically runs through that scatter plot? That's what we want to answer. And that's what the equation of the regression, that brings us to our title, the equation of the regression line. When we find that equation, that's the equation of the regression line. Okay, so it's going to be another formula. And it's going to be feeding on, and it's using something from the past that we've talked about. Y equals mx plus b. There's a way that we can get the slope, and we can get the y-intercept, and then we're going to have, that's going to give us an equation. Right? That's going to feed us an equation. So here's the formula. There's an actual formula. It's not that long, so I can write it down myself. To find b, there's a formula. Here it is. You take n of the sum of the xy's, and you can, sorry, that little symbol, that sort of the Greek symbol there, the sum of the xy's, and you can go refer to, I can show it to you again when I go down here, but I want to get this whole formula up first, minus the sum of the x's times the sum of the y's, the sum of the y. That's supposed to be just a parentheses, and this is supposed to be special symbol of sum. Okay, that's the numerator. Slope. Remember, slope has a numerator and denominator. Y minus y, y1, y2 minus y1 over etc. That's what's happening here. So then beneath that is the n, which will be 10 again, if you remember. And then that sum of all the x squares minus, that's a minus, not an equal, a minus, the summing up all of the x's squared. And that's going to get us the slope. That's going to get us that m, right? That's going to get us the slope. I apologize. That's going to get us the slope. Okay, fine. So now it's going to get us the slope. So fine. What about what they call value A? For some reason they call this value A. Okay, right. In the book it's going to be this way, but we would never do this. We would call this the M. So I'm going to do it the way that you're used to. And we would call this the B. Somehow the book decides it has a different way of doing things. All right, but anyway, I'm going to do it the way that we're used to. So this is our y-intercept. So this was our slope. And this is, you sum up all the y's, minus b times sum up all the x's. Sum up all the x's. Okay. And divide that by n, and you're going to get the y-intercept. Okay, now let me show you where you'll get the numbers from. We'll get the numbers, all our numbers, from here, from right over here. We're going to be able to get all those numbers. They're here from exactly like we did in the last video. Let's get back to what we were. And that's where all my numbers are coming from. So what does it turn into? As far as the slope is concerned, when you feed in all the numbers, and you can go see that right on video number 30, you feed in all the numbers. You can see that on video 30. Feed in all the numbers, and you're going to eventually get 2.78. Let me show you the some of the numbers. 10 times 100, it's going to be 10 times 113,000. They're all those numbers that we had in the video 30. 865 minus 572. All those numbers come from there. You can look it up. Times 1,750. Okay. Divided by 10 times 37,802. All those numbers come from there. We don't have to do anything. The work is already done. Minus 572 squared. And all that comes out to approximately 2.708. So our slope is 2.708. Okay, that's the slope. Sorry, this is a little bit mixed up, but I'm running out of time. I can't afford to go over 15 minutes. It won't work. Hold on. So what about B? The story with B is that the numbers are going to turn into 1,750, 1,750 minus 2,708. Again, all those numbers will come from where the video 32, video 30. 572 times 572 divided by 10, and B turns into 20.102. Okay, so here's my B, here's my slope, here's my M, here's my slope. Where do I put them in? I put them into the equation, M and B. Here's my equation, and here's what they want. The equation, they want the equation of the line of the regression line, or the line of regression. So my equation turns into y, leave y alone, get your M in there. My M is 2.708 times x, plus B is 20,102, and this is 2,708. This is 20,102. There it is. So there's the equation. They have it a little bit different in the book, but don't worry about the book. We're what we're used to. So now, but they for some reason, he likes to put y equals the first number and then the x afterwards, something we're completely not used to. What can you do with a line of regression? You can make a prediction. You can use that the line of regression to make a prediction, since there's a correlation between the beds and we've pretty much established this. There was pretty much of a correlation between the beds and the amount of personnel. So you can ask, hey, what would be if you have a place that has if you have a hospital that has, by way of example, 30 beds. 30 beds. What if the hospital has 30 beds? How much personnel would they have? And you just plug it in, and whatever you get for Y, you do these numbers, whatever you get for Y, you will have the number of personnel that it's going to require. You do these numbers, you'll get something on the order of 196.12. I'm sorry, I don't want that example. I don't want 30 beds. I want 65 beds, because I have that number in the book. 65 beds. You plug in the number 65 beds, because I have that number available to me, and you would need 196.12, which is really 196 people as personnel. You can make that prediction once you have the line of regression. Okay, we stopped this video, and I hope it's under 15 minutes.